Hi, so this video is about section 9.2, or at least part of it, where we are going to specifically focus on doing a significance test about a population proportion. We're going to go through our conditions again. They're actually exactly the same as our confidence intervals. Then we're actually going to perform a test, and I don't think in this video that we're actually going to get to these bottom two check marks. We'll talk about those in class together. So we're going to go through and kind of give an example as we go through this section as well. So it says, recall we have a basketball player who claims to be an 80% free throw shooter. In a simple random sample of free throws, he has made 32 out of the 50. So again, they have a proportion. So this is related to confidence intervals. This is our p hat. And this is much lower than what he claims. So again, just kind of keeping in kind of loop of what we know that n is that he's shooting 50 free throws, and now we know that his sample is, again, 32 out of 50. So that's our p hat, or written as a decimal or as a proportion, 0.64. And so the point of a confidence test is to wonder, do we have convincing evidence against his claim? Meaning, this is how we would write it. He claims to be an 80% free throw shooter, but we want to know if there's evidence against his claim that he is less than an 80% free throw shooter. And again, you always define what P is. P is his actual proportion of free throws that he makes in the long run, not just the 50 from the game or from whatever he was doing in practice, but in the long run. So that's why we always define our parameter. Parameters do not have any hats on them. So I'm actually going to write this over here so that we can refer to it later as well. So our null, again, is that P equals 80%, and our alternative is that P is less than 80%, and P stands for, I'm going to say, proportion of free throws in the long run. So just like we did in Chapter 8 when we were doing confidence intervals, we have to go through our conditions. Our conditions are the same. We have to know, is it from a random sample or a randomly designed experiment? And when you're shooting free throws, every shot is random. So we would actually write that down and check it. So let's go over here and write that. So it's random. Random. Each shot is random. The 10% condition. 10% condition, again, is they write it as a fraction. We've been writing it is he shooting population of shots? So is he shooting more than 10 times our sample? So does he shoot more than 500 free throws in his entire sort of career? And I would argue that yes, probably. And then that last one, the large counts again. This time notice that we want to know is n, and they use a p0 greater than or equal to 10, and is n times 1 minus p0 greater than or equal to 10. So it's not the p hat anymore, it's related back to your null. So when they use the sub-zero, they're saying that. So this would actually be, is 50 times 80% greater than or equal to 10, and is 50 times 20% greater than or equal to 10. And in both of those cases, yes, that's true. So we've met our conditions. So same conditions as before when we were doing confidence intervals. The other thing that you have to know is when you're carrying out a significance test, you have to know the shape of the distribution. And we kind of cover that when we're doing our large counts. We know that it's going to be normal because it meets that sort of large counts condition. But if something's normal, you should always know what's the mean and what's the standard deviation. So we learned that the mean of proportions will always equal sort of your parameter. And so that's always going to be the same as your null in this case. And our standard deviation for our sampling proportions, again, we can use the null for this, is p times 1 minus p over n. So we're using the null now. It's different than when we were doing our confidence intervals where we're using our p hat. Now we use the null as part of our equation. So that's how they got their 0.0566. So related to your large counts, once you know that large counts works, you then know that your normality condition is true, but you should know your mean and your standard deviation for your normal situation. So once you have sort of all of that plan, all of those conditions met, again, what a significance test does is it uses sample data to predict the strength against the null. So again, here are some principles that apply. Test compare a statistic, so our p hat, from sample data with the value of the parameter. So we're comparing our p hat to our null. The values of the statistic far from the null, so the farther this is away from the null, give us more evidence. How much more? Again, that depends on a specific calculation. So what we're going to do is we're going to take our statistic, in this case it's going to be our p hat, we're going to subtract our parameter, subtract the value in our null, and divide by the standard deviation of the statistic, and that's what we just found down here when we were doing that calculation. So it's kind of, again, bringing in all of our aspects from chapters 7, 8, and 9 now together. So here's kind of what they were, again, saying, plugging in our actual values. So what we're going to do is we want to know how far away was our sample result from the null, and we want to do it on a standardized scale, so that's why we're using a test statistic. So they refer to that as being a test statistic. Our free throw shooter, again, had that was our p hat. There was our null, and so that's how they plugged it in. Statistic, p hat, parameter, our null, standard deviation statistic, what we found, and that actually gives us a z-score. So we were talking about it being normal. That's why we calculate or get a z-score. Obviously, then if you get a z-score, then you can look it up into the normal table, the z-table. So the shaded area under the curve shows the p-value. So really it's just, again, another name for probability in your curve. So this is saying 0.64, that was our statistic. And that shaded region shows that the probability of shooting or making 64% or less free throws is, if he's an 80% free throw shooter, is only 0.0023. So again, it's written another way, if the null is true, so the player makes 80% of his free throws in the long run, there's only a 2 in 1,000 chance that he would make 32 of the 50 shots. So that p-value is describing the chance that we see our results if the null is true. That's going to be one of the questions they ask you a lot of. We did that in 9-1 as well. So again, just summarizing what we just did. To perform a significance test, we state the hypotheses. Did that at the top of our sheet over here. Then we check our conditions. Did that down here. Then they showed us the calculations for that test statistic, and they showed us the p-value from the table. And then we want to start to draw a conclusion. So again, the same steps that we were doing when we were doing confidence intervals, they're in there. State, plan, do, conclude. There's obviously a few more sections or parts to it as we're going through it. So again, our conditions were met. The z-statistic has that approximate normal distribution, so that's why we're using the normal curve to find those p-values. So the generic formula of what we were just doing when we were saying statistic minus parameter divided by the standard deviation of the statistic looks like this. And we refer to our test or our inference procedure as a one-sample z-test for proportion. Again, making sure that we have a simple random sample. They're doing their statistic minus their parameter divided by the standard deviation of, in this case, using the parameter, and then you find the p-value. If your statistic or your alternative is saying that you want something greater than the null, then you're looking at obviously the upper tail. If your alternative says you want to find it less than, so evidence for less than, then you're looking in the lower half of the tail. And if your alternative is you just want to know if there's a difference, then you actually have to calculate in both tails. So we have one tail, and then when they ask you, is it two-tailed, that's what two-tailed is referring to. So that's kind of the general overview of what section 9.2 is going to ask you to calculate and do for a significance test. There's obviously more details as it relates to our type 1 and type 2 errors and the chances of those things happening, and we'll talk a little bit about that in class together. If you have any questions, make sure that you come in. Again, the major equation for this section is written right here. Our conditions, again, are the same, and we want to prove that it's normal, so we're always going to find that mean and that standard deviation so that we have, again, that standard deviation is right here. Thank you.